Hello everyone. Today we are going to explain the Pset4 filter less comfortable. So as you can see, I've just finished it here and I have submitted the file and everything worked. So I'm gonna go briefly on how I made each filter. You will find on YouTube many videos that explains in details, but I'm just gonna point out some of the problems that might get you stuck, and your code might be fine, but this exact problem might make you struggle for days, basically. So I'll just point out what you need to take care of, basically. So first we have the grayscale. Okay, what I did here is taking the average of each red and green and blue value that we have for each pixel. The problem here where you could get stuck is that you have to cast each value as a float, because if you divide by 3, like if we didn't have cast here and we added blue and green and red, and then we will get from this addition values that have decimals. So if we divide that by 3, it will treat it as an integer. So we will lose all the values that we have at that decimal point, which will lead to getting an accurate value. So it won't be accepted by CS50. So you have to make sure that you use casting the values as float, or you could just add 3.000. So this will make it that you will be dividing by a float instead of an int, or a double, as it says. Like if we make it, yeah, anyway, if you divide by 3.000, it will give you the accurate value without casting it as float. Then I took the average value, round it, which is really important, and to have the round function be active and not getting an error saying you are using an implicit function or something like that, you have to use the mass.h library. You have to include it. This helper.c does not include a lot of the important libraries that you might need, so you might as well take it from the filter.c. okay, just copy and paste the libraries from filter.c and add it to helper.c, so you will have everything you need. So after including mass.h, the round function will work, and you will get an accurate value for the average that you need. And you will keep adding the average value for blue and green and red, and keep looping until you get the final result of getting the picture to get great. So if we try that, let me get the command. Here we go. Okay, and you have to write the file name. I will choose Stadium and make it gray, and we run the program. This is before and this is after. So the gray part worked, the gray filter worked. One note I want to add. At the beginning, when you want to make the file, like after you write the code, okay, and you try to make, if you're using VS Code, I don't know what will happen if you are using code spaces from GitHub, but I'm using VS Code here. So if you write make filter, okay, let me resize that. Okay, this is better. Okay, let's check. Or yeah, okay. Anyway, so if we write make filter, it will not create a new compiled file for you if you already compiled it once. Because if we come to the make file and how it works, because it was not explained, basically you have to write make and then write the name of the build that you want to like compile or run. So here it was written filter. So if you write make filter, it will compile once without any problem. But if you make any adjustments to helpers.c and you want to compile it again, so you write make filter, it will say it's up to date. And do not get this is incorrect. Like it's not up to date. It's just stating an invalid value, or I don't know how to explain it. But basically, because there is the word filter here, you can see this, like for some reason, intersects or like makes a failure for the file when the name of the command is in the command line also. I don't know why exactly, but to fix that, you either do something as to do a clean build besides the filter build, or the easiest route, you just change filter to something, to another name that you might like, and save the file. What I did is changing filter to Insta for Instagram because filters, and when I make the file, I just write make Insta and it works. So that's one point. And like if I write make Insta, it just runs perfectly, as you can see. So that's one point. And the second point, when you want to actually run the file, you will take the command line from the website for the test you want to do. So for example, the gray filter, I took it, I copy and paste it. We have G here. We only have to change the in file name to the name of any picture we want to change or make the filter on. So we take from the images file folder, from the images folder, we take the picture and put it next to the other coding files to be able to access it, and run the file, run the command line, and the filter will be applied on the image basically. So this is an important note I wanted to clear out. Okay, so going forward, after Grayscale, we have Sepia. So sepia will turn the picture into a brown reddish kind of picture, like vintage style. So how we do that is following a set of formulas that are included on the website. It's basically straightforward, like two nested for loops, and we have the three formulas. What we have to take care of is using round to get the value rounded to the closest number. And I added those three lines to make sure that if we have a value that is over 255, if we have a value over 255, it will print it out as 255. You can do something else than this mess that I made. I found it on a YouTube video. Thanks to whoever made it. Basically, you do a function that will limit the values that are coming out to be limited to 255. So if you do this function, you will be able to skip those three lines. Okay, so that's Sepia. If we go to the next part, we have reflect. So basically what we do in reflect is changing, like if we have this matrix or an array, a 2D array, we basically are changing or swapping the values from the we are basically swapping the first value and the last value, and the second value and the third value, and so on and so forth. That's all about it. It's the same swap function that was explained in the lecture. We just adjust it and use it for this example. As you can see, I have a temporary variable, and I'm giving it the value from the first part of the row, like this part, and changing the value of this basically the temp here stores the value of the first element, and then I change the value of the first element by the last element, which is I and n, and then gives the value of the last element that stores the value of the first element in the last element. Basically those three lines. You can do something else, which is setting something like this, those three lines, to just skip all those stinky, basically copied lines. I didn't know that you can copy all the values by just writing image and I and j, but that's it. I had to copy each value, like blue and red and green. You can do it better by using this method, as you can see. Also, an important note, because we are swapping values, we only walk or loop until the middle of the row. That's why I'm using here widths divided by 2. And the n value represents the width minus 1, which is really important because we are looping for the values of the array, not the count of the array. Because if you have, like, ask yourself, what is the width of this row, you would say 4. Okay, this is the width. But if you number it, you will get 0, 1, 2, 3. So you are looping until 3, not 4, which is really important. This is really important. So 4 minus 1 we will give you the value that you are looping for. So that's why I'm subtracting 1 from width here. Okay, so yes, this have been done here. And to make sure when the value of j, which is the value coming from this way, and the value of n, which is coming from this way, because I keep subtracting from it, as you can see here, to make sure that they do not go over the line and swap values that are not supposed to be swapped, I added this if function, if statement. If j does not equal n, the process we are doing will be continued. If j equals n, which is after this point, like if we are here and here, and for the next step we continued and got to the start of the loop, and we found that when we increased j to 3, and we will reach the point that we have values n and j having the same value, which is incorrect and should not happen. So that's why I added this statement here. Okay, so for the last part, we are going to blur an image. Okay, so for blurring the image, first you have to make a copy from the image array, because if we are changing the values of the array step by step, when you calculate the values for the next pixel, it will take from the already adjusted pixel, so you will get an incorrect value. So we have to make a copy. As you can see here, I declared a new array that will be the same size as image. And after declaring this array, I made a nested for loops to copy the values from image and store it in copy. I think that you can do the same that you could do here with swapping. Yeah, something like that. Instead of copying each value, and for the part where we want to check each pixel around the pixel we want to change, and basically get a sum of the values. First we introduce some for red, some for green, some for blue, and a count. And we will need 4 nested loops. I think that you can't solve it without 4 nested loops. I saw a lot of people talking about it, and this I reached to this 4 nested loops before looking it out, but you can't. I think that you can't reach another solution. If you have another solution in mind, or you did it and you're just checking what I did, please write it in the comments. So the first loop, it states which row we are on in the array we are adding to. The second loop states the column, and then the inside two loops are going to be the matrix we are going to investigate basically. So if we clear this, okay, and like if we are at pixel 1 and want to calculate the values for it, you have to calculate this part. Okay, we are creating a 3x3 matrix. This part we do not want to calculate. This part also, this part also, this part also, this part also. So the count value should give us only 4 for this one, this one, this one, this one, and making a submission for each of its values, for the red, for the green, for the red, for the red, for the red, for the red, and so on for the green, and for the blue. So how can we do that? So if we say this will be -1, this will be -1, this will be 0, this will be 1, this will be 0, this will be 1. If we look at it like that, we can get the values for the two inner loops that we want to make. So if we say that k is rows and b will be columns, okay, so we are talking about rows. If we get k to be k equals I, because we want to make k and b in reference to I and j, if k equals I minus 1, it will give us, because we are at pixel 0, 0, give us k equals -1. So this is the place we want to start looping at. This is the place we want to start looping at. Okay. So if we say b, we should say the limit for k first. So the limit for k should be I, k should not be I plus 2, because if we substitute I with 0, so we will get k equals 2. Let's see where that takes us. We have -1, 0, 1, and when we go to the start of the loop again and change k by 1, we will get k equals 2, which is the value that equals to I plus 2 here. So this will stop the count for this row, and we will go to the next row. The same concept can be applied to p. So we will say we will say that p equals j minus 1. So if we say that at first j is 0, so b equals -1, this is the start, and we want to make the limit range, it will be j plus 2, because if you substitute by 0, we will get 2. So if we walk -1, 0, 1, the start of the loop, it's gonna be 2. We want to stop here. So both of them will be working okay. So what do we want to do inside of those two loops? Basically, we don't want to write anything if we have if we are at this spot, this spot, this spot, this spot. We want only to write values when we are at 1 or 2 or 5 or 6. So how we gonna go about that? First, we will say that we don't want any values that will be in less than 0. So that's why I wrote B is bigger than and equals, which is really important, writing this equals. It took me 2 hours to notice that I didn't write it, and I was getting a really weird results because I didn't take note on adding it. Yeah. Okay. So B is bigger than and equals 0. So this makes sure that we are in the columns that are in this array. avoiding this part, and using K is bigger than and equals to 0 will make us avoid going to these rows. So B avoids those columns, and K avoids. You get the point. If it's this over this, basically this rule will make us avoid the negative part. But there is also this part. Okay, so here we don't want to go over the height for K, and we don't want to go over the columns for B. So if K equals the height, we should stop. The same goes for B with forwards. So this if statement is really important. We have B is bigger than and equals 0, and this is important, K bigger than and equals 0, and K is less than height, and B is less than width. So if this if statement is true, this will mean that we are somewhere in here, which we want. So if we say, okay, we are now here in searching for values, so we will add the value from the copy matrix. We'll add the value of red to the sum of red. We will add the value of green to the sum of green. We will add the value from blue to the sum of blue. And we will plus 1 for the count. So now this is really important because we want to know how many values we added in the addition, to be able to know how many values we want to divide by. This is the number of values we want to divide by, because we want to get the average value. So every time we add something, add a pixel to the sum, we count it. So rule of thumb basically is if you are at this point, or at this edge, or at this edge, or at this edge, you will get a count of 4 values. If you are here, let me change the color. If you are here, 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 you will get 6 values. If you are here, away from the edge, you will get 9 values. So this is your guide basically. You either get 4 or 6 or 9. This was really helpful when I made some printfs here to see how many counts are made, to check if I got the exact count that I needed. It really helped me to find the error I was making, because you can't really debug this file because it's have an inputs as argument command line arguments. If you want to debug it without using those printfs lines that I wrote, you'd have to make like a test file and copy the things that you want to test and see if the inputs, you have to input the values manually, and it will be a hassle basically. I'll just wrote some printfs. They are really helpful when I want to diagnose a file to find the error. So after counting, we will round the values of the sums, some green, some red, some green, some blue. Round the values and divide by the count. It will be either 4 or 6 or 9, we don't care. It will be automated. And then we register the values we get in the output array that we want to print at the end, which is image. So we assign the sum red to image ij rgbt red and so on. And after this part, like we have done the 2 inside loops, the counting and everything beside that is done inside the j loop. And before getting out of the j loop, which is a number of columns, and going to the next row, going for the next we have to set all the values to 0. This is something necessary when doing sums, because you don't want the next values to add to the already written sum for R and J and P. You want to get a new value for the count, for the sum, for everything. So we set everything to 0 here, and that's it. Like that's how you do Blur. So let's run each file to see the resulting. So we did gray before. This is the output file. If we want to run sepia, here we go. If we want to run reflection, here we go, reflected. It won't show really in this file, but this picture was okay. And finally you want to put run, and it's blurred. So that's it, guys. I hope the notes I stated might be helpful to you. If you have another solution for the problem that you want to point out, something that will make it quicker, please leave it in the comments. And thank you, and have a nice day.